Hello folks, today we are solving Leetcode 42 trapping rainwater. This is one of the most classic problems asked during the code interview. So let's look at the input first. We're given a list of arrays. Like instead of staring those numbers, we can visualize this in the graph. So the black area represents the bucket and the blue area represents the water, and a direct observation is that a bucket can only trap water if there are black bars on both sides, and the amount of water it can trap depends on the lowest bar. So we can derive a formula out of it. For each index I, the water is equal to the lowest bar minus the current height, and the lowest bar is the minimum of two values. One is the left maximum bar. Now let's walk through this formula in runtime. So given the index is 0, and we are going to search for the left maximum bar, which is 0, and the right maximum bar, which is 3. We're going to take the mean of it. It is 0. So the water trapped is 0 minus height 0 equal to 0. So the first value is 0. Then we're going to look at the index 1. So for index 1, we have left maximum bar is 1, and the right maximum bar is 3. So taking the mean of it is 1. So 1 minus the current height is 1, which is 0. Okay. Then we're going to look at next index 2. So the left maximum bar for index 2 is 1, and the right maximum bar, which is 3. So taking the minimum of it is 1, and the current height, which is 0, so the water trapped is 1. And we can take a look at the next index, which is 3. So for 3, the left maximum bar is 2, and the right maximum bar is 3. So taking the minimum value of it is 2, and the current height is also 2. So the water trapped is 0, and we can continue to compute this. So now let's turn this formula into code. First, we need to iterate for each index I less than the current height, array's length, and then we will have a maximum bar and the right maximum bar. And for each iteration, we need to scan for the left and scan for the right. We're going to have an index j. First round of j is scanning all the way to the left, and we're trying to capture maximum left value bar. Similarly, we're going to scan all the way to the right to capture the maximum right, and then we're computing the water trap. So we also need to define, and then we return. Let's do the big O analysis for this code. The time is O(n) squared because for each iteration, we're searching for the left maximum and the right maximum. And for the space complexity, it is O(1) because we are not storing anything in the array. So next, interviewer may ask how to improve your code. The issue with the brute force algorithm is that we're computing left max and right max during each iteration, and this costs us time. So we can use dynamic programming to further optimize the time by pre-compute a left max array and a right max array. So for example, left max array, for this one, we're scanning left to the right for each index 1, 2, 3, 4, 5, 6, for example. So we have 0, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3. And for the right max array, We are scanning from right to the left. We have one, two, 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 three, 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 three. And here we obtain the left and max bar, and we just we can compute the lowest bar in one iteration. Let's turn this into code again. So far, we have talked about the brute force, which takes O(n) squared and O(1). We have talked about the dynamic programming, which takes O(n) and with O(n) space. Now, the interviewer may ask, can you further optimize? Yes, sure. We can use two pointers. And the space is just going to take O(1) and time is O(n). So how does this work? So still, let's go back to the original formula with lowest bar minus the height. Instead of manually comparing those two, we can add a condition. So the condition is the left bar. If the left bar is smaller than the right, then we can compute water by the left max minus the height. And else, the water is right max minus the height, the current height.